This is a podcast of Scripps Institution of Oceanography at UC San Diego. In August and September 2005, a research team led by Scripps Institution of Oceanography set out to study a place like no other on Earth. The Line Islands in the Central Pacific Ocean are an archipelago 1,000 miles south of Hawaii. There, the scientists found an ideal destination for a comprehensive examination of coral reef ecosystems. The reefs around 4 of the islands display degrees of damage that are in direct proportion to the amount of human habitation each has experienced. Each island presented a distinct case study of human disturbance, from corals that had been heavily damaged and overrun by algae, to the virtually pristine with healthy and vibrant gardens of coral. In Part 2 of Paradise Redefined, marine ecologist Enrique Sala and Stuart Sandin talk about the results of the Line Island expedition and hope for the future of coral reefs. They describe how the exhaustive travel and dive schedule in the field was the easy part. When they came home, it was time to decipher all the field data.
Probably the most difficult part of this project was the post-cruise. When we were in the field, it was very easy because everybody knew what they had to do: count fish or collect water or count corals. But then when each component of the team had their results, then we had to put them together. The person who studies viruses and bacteria doesn't speak in the same terms as somebody who studies large sharks. So when we got all these pieces of information, we had to put them together. It was difficult, frustrating, painful in some cases, but especially exciting. It was very, very exciting. And at the end, I think that we came up with the single most comprehensive picture of the entire coral reef. And all of this work was totally worth it.
What we found on Kingman Reef and Palmyra Atoll was that there was more fish in the predatory guild than there were in the prey guild. If you want to think about it a different way, you can imagine a pyramid, and we could call this a trophic pyramid. Typical view is like an Egyptian pyramid. There's more prey at the bottom of the pyramid feeding the predators on the top. The Serengeti has more herbivores, more grass eaters, more gazelle than they have lions. But what we found was on Kingman and Palmyra that there were more lions than there were gazelle. There were more predators than there were prey. And that was really surprising. Not just was there an increase of total biomass as people stopped taking fish out of the system, but there was this change and essential removal of the predators.
A coral reef is like a big machine with millions of components, thousands of species and millions of individuals that interact. If some of these pieces are missing, the machine malfunctions. Would you get on a plane knowing that there are 10 screws missing, even if you don't know what these screws are for? All species count on a coral reef. Right now, we believe that what's natural is what we saw when we were kids. In the case of coral reefs, we believe that natural coral reefs are the first coral reefs visited by scientists. Unfortunately, most of these coral reefs were already seriously degraded and impacted by humans when we started our modern science. So we don't have a proper baseline. And our expectations of what natural are low. And our expectations of what we want for the future are also very low. So we need to set the baseline back in time.
The one thing that remains an outstanding question is whether corals can regrow, and what are the conditions under which corals actually can come back. One thing that we found on the islands of Kingman and Palmyra was a lot of hope. We saw a fairly intact coral community with corals regrowing, juvenile corals settling, and we didn't see that on the more southern reefs.
For the researchers, Palmyra represented a special case. It was the perfect example of a place in the midst of recovering from earlier damage. During World War II, more than 6,000 U.S. soldiers were stationed at the atoll. Their construction projects and discarded equipment left a lasting impression on Palmyra corals. The researchers saw clear evidence of that impact, but they also saw signs of resurgence and evidence that ecosystems can recover from serious setbacks.
What we found, instead of just a dead coral reef, instead of just an algal-covered benthos, what we found instead was rock substrate that had been cleared of most of the algae and had a number of small coral recruits. It looked as though the coral community was recovering, and this has large implications for the world. In a day and age where we're concerned about the ocean's water is getting warmer and then becoming more acidic and affecting the survivorship of corals. What these results showed us was that there's hope in local protection. Climate change is hitting Palmyra, it is getting warm water, but the coral community is still restoring and is still recovering. How is this happening? Well, it's probably due to the local protection. With the intact fish community, without pollution covering those waters and filling it with bacteria, the corals are able to grow.
In my opinion, the most important thing we learned from our expedition was that if we have an ecosystem that is intact with all its pieces, this ecosystem is able to recover from disturbances such as overfishing and global warming.
Based on the success of their 2005 expedition and the new questions that emerged, researchers returned in 2006 for further studies of Palmyra and Christmas Island. They will be going back a third time in August 2007 for a detailed analysis of Kingman Reef and its virtually pristine conditions. In 2009, the team plans an even more ambitious voyage that will focus on the southern sector of the Line Islands, an area largely unknown and unexplored. They hope to understand the mechanisms involved in preserving coral reef ecosystems and perhaps create the knowledge that will save them.
We're going to begin that expedition in Tahiti, and we're going to work our way north all the way up to Christmas Island, touching on each of these islands. The Southern Line Islands expedition is going to allow us the opportunity to understand what is the minimum critical size that a coral reef needs to have in order to sustain full ecosystem function. Put a different way, what's the smallest atoll that you can fit a functional community of sharks, large snappers, and the associated biota of herbivorous fishes and invertebrates to sustain reef function? We don't know this right now. We don't know this because we have very few examples of what an intact coral reef looks like. And the application of these data will be particularly important. Across the globe, one of the favored conservation tools is to create marine protected areas. Marine reserves, places where fishing is not allowed. And there's an ongoing debate as to what's the right size for a marine reserve. What's the minimum size that we need to make a marine reserve to restore functionality of the coral reef, to serve the benefit that avoiding fishing and avoiding pollution could confer on that coral reef?
We need to show to the public what the ocean was like before, so we can all together decide what kind of future we want.
This is Wendy Hunter Barker for Scripps Institution of Oceanography at UC San Diego.